The problems that we are presented with on this page, in this packet, have two facts about some geometric figures. These facts form a system of equations, and then the system can be solved in a variety of ways. Okay? In this first problem here, we're talking about a rectangle, and we know that the area is 384, and we know the perimeter is 80. So it gives us the option of filling in this table for area, and it gives us the option of filling in this table for perimeter. This is one of the ways it wants to show you, but this is one of the longer ways, and I think most of you would not choose this way in a typical situation, because what you would do is fill in the table and then look for the point they have in common, right? That would be the solution of the system. Again, I think most of you would probably not choose that way, and so I think it's going to be enough with us just talking through how you would do an example like that. Fair enough? Okay, so it does ask for the equations, and I do want to fill those in because I want to make sure you can pull equations from sentences. Can you tell me what equation would relate x and y if we're talking about the area of a rectangle being 384 feet squared? So xy equals 384. Okay. What would it look like if I had solved for y? Y equals, very good, 384 over x. Okay. What would the equation look like for perimeter if we knew the perimeter was 80? Well, to start off with, it would be, yes, 2x plus 2y equals 80. And if we solved for y, I'd subtract 2x on both sides and then divide by 2 to get y by itself. But dividing everything by 2, I would end up with y equals 40 minus x, right? Okay, so from this point, thinking back to what we did yesterday, what could I do? Several different options. I could graph it, absolutely. I could put both of these in a y equals and graph. I could set them equal to each other because they both equal y, so they both would equal each other. You know what this crazy kid said last period? She said, could you do substitution? I'm like, we have not even talked about substitution since like October. Can you? Can you do substitution here? Even though we didn't talk about it yet? That's a skill that you know. It's a skill that you have, right? You could take this y value and put it in right there to solve for x, couldn't you? Or even, I mean, that's really much what we're doing when we substitute, or excuse me, when we set these two equal to each other, right? I know y equals 384 over x, and I know y equals 40 minus x, so I'm taking this value and substituting it in for that y. Or taking this value and substituting it in for that y. So is substitution a viable option as well? Absolutely. Okay? So let's turn the page and look at number 4. Because you see there's no tables here, are there? There's a very, very, very clear space, however, for your work. That is so great if you're going to put them in the calculator. What are you gonna do in the workspace? Are you going to write, I put it in the calculator? Oh, you're going to transfer your graph to the paper, aren't you? And circle the intersections, because that's what you're looking at. All right? Show me some work so that I know how you did the problem. Fair enough? Okay. A rectangle has a perimeter of 14 inches and an area of 8 inches squared. Find the dimensions. Are we told enough in this one sentence to be able to find the dimensions? Because we're dealing with a rectangle, we know stuff about a rectangle, right? We know how to find the area of a rectangle. How do you find the area of a rectangle? Length times width. And in this case, that's x times y. And again, in this case, it equals 8. That's the area, right? Okay. So what about the other equation? 2x plus 2y equals 14. So how do you want to solve this? First of all, it gives you like a hint if you're confused. It says maybe you should try substitution and then use the quadratic formula. See how this one says maybe you should try graphing it. See how this one says maybe you should try substitution. That's not required. That's a hint. See, you may see hints about using those suggested methods, but if you're more comfortable using another one, you know that doesn't bother me. Okay? So how would you like to try this one? Substitution? Okay, so what are we going to solve for? X, Y, X, or Y? First X? Is that what you said or no? Okay, so if we're solving for the first X, X is going to equal 8 over Y. Absolutely. What am I going to do with that value? So 2 times 8 over Y plus 2Y equals 14. So 16 over Y plus 2Y equals 14. Now what? Multiply everything or both sides by Y, right? I got to get the Y out of the denominator. So I'm distributing the Y here and here. So I get 16 plus 2Y squared equals 14Y. Why would you subtract 14Y from both sides? Very good. It is a quadratic, so I need to get it equal to 0. Okay? So, can I do 2 steps at once here? Does anybody care about that? Can I go straight over here to Y squared minus 7Y plus 8 equals 0? Did I go too fast? Did I skip too many steps for you? If I subtracted 14Y from both sides, got it in order, and then divided everything by 2, are my signs right? Okay. So how are you going to solve that? Ooh, that looks factorable. What multiplies to be 8 and adds to be negative 7? Negative 8 and positive 1 multiply to be negative 8. So it's a trick again, just like yesterday, isn't it? Dang it. So how do I have to solve it? Quadratic formula, right? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So x equals 7 plus or minus the square root of 32. So 49 minus 32 is 17 over 2. Huh. Now before, when we solved with quadratic formula, that was totally fine to leave the answer like that, wasn't it? Does it make any sense now? It doesn't, does it? Okay, so I need to have my calculator and I need to be able to say 7 plus the square root of 17 divided by 2. So x equals 5.562. And I need to be able to say 7 minus the square root of 17 divided by 2. And I would get 1.438. So this is kind of intriguing. These are the two values I got for x, aren't they? So what do I have left to do? I have to find y, right? I have to plug them back in, substitute them back in to find y. What would you choose, first or second? Oh, look, this one's even already solved for x, right? So couldn't I solve it just as easily for y? Wouldn't y also be 8 over x? So if y equals 8 over x, all I'm doing is dividing 8 by this, aren't I? 8 divided by 5.562. So if x is 5.562, then y is 1.438. Well, that looks familiar. Where have I seen that number before? Oh my gosh, it's my other x value. So if I know my other x value is 1.438, what's my other y value going to be? 5.562. Will it always work that way? No. It happened to this time. So while there are two possibilities, it's basically saying like this, where this is x and this is y, right? It's this rectangle stood up on its end. Same kind of dimensions, we just call one x and one y, and in the other one, it's the other way. One's x and one's y. Okay? Any questions about that one? Number 4. Okay. What about 5? You don't like it? It probably doesn't like you either. The short leg of a right triangle measures 6 centimeters. The hypotenuse is only 3 centimeters longer than the other leg. Find the lengths. So I have to have at least 2 equations. Do I have 2 equations here? What are they? X plus 3 equals y. Anybody know any sort of formula that you can use with triangles? Oh, Pythagorean theorem. How would we set that? You don't have to worry about spelling it right now. We won't have a spelling test anytime soon. In here. So x squared plus 6 squared equals y squared, right? Okay. So what do you want to do? How do you want to solve this? It does say substitution. We can do what it says, or we could try our own way. It's totally up to you. You want to do graphing? If we do graphing, what is y equal in this case? The square root of x squared plus 36. Right? We can't just take the square root of both numbers there. That's not what it's asking. Right? Anybody see any errors about anything I just wrote? I'm square rooting that whole side. I'm not square rooting each individual term. 4 plus 25 equals 29, right? But if I took the square root of 29, does that equal 2 plus 5? No. Okay? That's why we can't do that. All right, we'll go with it for a second. So you want to graph these two things? So let's go to my calculator and the graph. And I'm going to put in x plus 3 for one of mine. And then I'm going to put in, for the other one, the square root of x squared plus 36. So I need to do menu, analyze the intersection. Can you read that? Okay, I can't, so I'm going to move it. $4.5 and $7.5. X equals 4.5, y equals 7.5. What's my work look like? My graph. Questions? Would it have worked out the same way if we did it another way? If I did substitution and substituted this value right here for y, x squared plus 36 equals x plus 3 squared. Well, x squared plus 36 equals x squared plus 6x plus 9. That's a quadratic, isn't it? God bless you. So if I subtract x squared from both sides, oh my goodness, it's not a quadratic after all, is it? So subtract 9 from both sides, 27 equals 6x. If I divide both sides by 6, x equals 4.5. 4.5 plus 3 is 7.5. Dun dun dun. Okay? I was just trying to show you that it does work out the same way, just making sure you know that. Okay? Please circle the following questions. Please circle number 7, 8, 9, 10, 12. Okay? 7, 8, 9, 10, 12. All right, those are the ones you're responsible for by tomorrow, but you have the rest of the period to work on it. Okay? Any questions?